Wow, these magnets are so strong. All right. Here's one. And here's one. Are they similar or congruent? Where do they belong? Up here or down here? I hear you. Yeah, not really. But I bet you're thinking these are congruent. No, remember, congruent means they're exactly the same size and shapes. Straight edge, curve, curve. But one's much bigger. These two belong in the similar category. We'll put them over here. Yep. These kids are similar to each other. They're not identical. Think of congruent as being twins. What if I put, this one and this one? You would say, yay, they're congruent. And I'd say, you were right. Let's put them over here. That's a congruent pair. Oh, let's try, this triangle. Let's see if I can use these square magnets. Nope. Hey, but you can see it. I don't love that. So I'm going to do this one. So we have a triangle, 1, 2, 3 sides. We have 2 identical sides and 1 long one. This angle right here is a 90-degree angle. I can almost see the congruent other half. Look at this. Yeah. If we had them both, it would be a square. So let's see. Is this one? We have 3 sides. That's what makes it a triangle. It has it does have 2 that are identical, but this one's short and this one's long. So these 2 are similar. Yep. But what happens here? Oh my gosh. Look at that. If you flip, one can fit inside the other. These 2 triangles, they have a right angle. That space in between makes a perfect corner. They make a square. This is a right angle and this one is. These sides match those sides. So these 2 belong down here. These 2 are congruent. I like them so much, I am going to I want to look at them. Yeah, I want to look at our congruent pairs. Congruent, similar. Let's have, well, we don't need those dotted lines anymore. Let's work on a square. What is a square anyways? All 4 sides are the same length. You have a pair here that are parallel. That means side by side. They never touch. You have a pair here, side by side. They never touch. And these 2 are perpendicular. Those are some words we need to talk about. Yeah. And geometry. I love talking about geometry. You know I'm going to do it just because I love it. What about these 2? Even if it's sitting like that, kind of looks like a diamond, but it's not. 90-degree angles on the inside. Yeah, it's a square. 2 squares. I can flip this one. This is called, and so let's flip. Nope, not even close to the same size. I could slide. This is called a slide. When I don't flip it over, I just congruent things, you can slide them if they're sitting on the page in the same. Like I can't slide this over. But if it was right next to each other, like this, I could slide it up, you know. So that's called a slide. That's actually another geometry term. You're learning some some big words. They don't usually teach you these in 3rd grade, I don't think, but I don't know. We're smart. We're ready. So these two are similar. They're going to stay up there. Yeah, let's see what else I got here. We've already talked about circles. What are these two? They're definitely similar. But what if I got rid of the bigger one and I made, ta-da, these two go in the congruent pile. I'm going to put those right here. What about this triangle? And are these two similar to each other? I almost want to say no. Kind of yes. They're both triangles. They both have 3 sides. But they're not the same shape at all. This is very pointed. They're both isosceles triangles. Do you know what that means? It's a isosceles. It's a triangle that has 2 sides that match and then one oddball. These two match, one oddball. I guess all of these are isosceles. If I were going to pick a similar triangle to this little doodad here, I would be picking this one. They're the same proportion to each other. Proportion means, in relation to this one, they're the same. Only bigger. They're magnified. Yeah. Proportion's kind of a hard thing to understand when you're little. It's a hard thing for me to understand when I'm big, if I was totally honest. Well, it's hard for me to explain. What about these two? This one and this one. What do you think? Well, I kind of gave it away, didn't I? I put them both in the congruent. They're down here in the congruent. Yeah. Well, let's see. Similar. Ooh, what about if I put this one up here? Yeah, he needs a partner. Seems like a he. Maybe it's a she. I don't know. These two are similar to each other. Yeah. Same shape, but magnified or shrunk down. Same shape, but magnified. Magnified is get bigger, shrink it down is. So these are some examples of similar. These are some examples. I'll take that one down of congruent. And let's see. Let's put the trapezoid back up here. Trapezoids always have 4 sides, but they're not as perfect as squares or rectangles. A square is a type of rectangle because it has a pair here that match in length and a pair here that matches in length and 90-degree angles on the inside. This has 90. They do match, and this is 90 straight, short, but then you have this. That's a type of trapezoid. But to be a trapezoid, you don't have to have 2 matching pair. I can have this side and this side, a short side. These 2 match, and then there. That's a trapezoid too. It doesn't look anything like this. So trapezoids are always 4 sides, but they don't have all the matching rules that that a square has. Square has to really match. Boy, I'm talking about shapes. At the same time, we're talking about similar and congruent. Well, I just love how everything in math fits together. You start talking about, shapes and sizes. All of a sudden, you're talking about flipping and you're talking about sliding. Yeah, I could slide this up. One can fit into the other. Pretend they're perfect. I'm trying to draw them and trace them and stuff. Let's use this little guy. Yeah. Because I cut them together. Yeah. Is this one congruent? No. Not at all. So it belongs up there with the similar ones, doesn't it? We could sort all day, but I won't. That's it. That was fun though.